Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, welcome to the continuation of the lecture on convolutional neural networks. Today I will follow up from from the previous video lecture where we look at some basic theory related to the convolutional neural networks. And we just want to see how we can use this CNN to solve a real problem. And the problem that I've chosen for the example is the face recognition problem. Getting back to our notes before, if you look at the uh, notes in chapter 5, we have look at this. I've talked a little bit about this in the previous videos, where my former student tried to detect the face image, okay, a human face, from a bigger image. So this is a problem that has been solved using many algorithms. I mean, it is available commercially even in your telephone, in your smartphone. So these are some sample face images. So what we want to do today is to look at how we can use the CNN not to recognize faces, but to recognize if we have a face, which student does the face belongs to. Okay, so it's a slightly different problem than the one discussed in the notes. Right. If you look at your e-learning, I have uploaded some files. This is the slides used in the previous video, and this is the one that we are interested in, where convolutional neural network is used. So if you open this, it's a zip file. Inside the zip file will be a Google Colab file and some data. So let's look at the data that we have. So these are image of former UTM students, right? If you Okay, so for example, this data has been organized for you. I mean, the size is correct. We have 7 students from labeled from student 0 to student 6. I've typically used 0 to 6 because in Python the array or the list starts with 0. So if you have an array of size 7, then it will start from 0 to 6. Okay, so if you copy all this into your Google Drive, so make sure the files are in you will have in some the same directory. So this is your program and this is the data. So you can just open this and run it. Of course, you need to mount. Okay, if you look at the file, it's not very long, but it is enough for you to get started with the CNN. So as before, you can mount your Google Drive. I've shown you how to mount your drive so that your program can see the data in your Google Drive. Okay, after you have mounted your drive, then you can see the location of your files which you just uploaded into your Google Drive. So in my case, I've placed it in this one, student face, and it is in the folder called image classifier. So this is up to you, but the critical part here is to make sure that the drive that you specify here is the folder that contains the pictures. Okay, the pictures of the students, basically the data. So I've define the subdirectory here to contain the data. So you can run the rest of the files. So you can just choose to run all. I will explain this in a short while. Essentially, while this is running, you can change the runtime type here to non-GPU or TPU. So if you are using convolutional neural network, especially if you have large data set, then it will get slower and slower if the data grows bigger and bigger and your network becomes bigger and bigger. So you can choose to use GPU, but in this case it's not necessary because the data that we are working with is very small. I think it's about 50 images, which is very small. I've just chosen the data to be small so that we can run it quickly. You can easily reuse this code, change it when you use a different data set. Okay. So once you've run it, these are the next part here is importing various modules, the libraries. Okay, I think I've explained it a little bit. Okay, you can refer to the appropriate manuals available in the appropriate website. Okay, to look at what each library has. Of course, we will be using Keras and TensorFlow. That's the main one. Okay, the one that I'm using is 2.2.0 RC2. So if you want, you can just uncomment this part. If you want to run it, maybe they will produce a different version later on, but I've included this line. I've commented it for now, but if you want it to run in the future, probably you need to uncomment this. Okay, that is just the basic starting up of the program, and then we prepare the data. So the data that has been used is it is 101 times 132 pixels, so the image is not very big. So for example, you can just see it's just a small image. And then we can assign the label, and then we can assign the training data. This is the code that will do that. Okay, I won't talk too much about it. So once you have done that, then the program will load the images into this list X. Okay, called X. So X contains all the images that has been loaded. So if you type this part len X, so it means that the total number of images that we have has been stored in the list X, and each item or each element of the list is an image of 101 times 132 pixels. So we have a total of 55 images. So this is very small for the purpose of CNN actually. But nevertheless, let's see how it performs. So this part, visualizing some random images, you can just refer to the text that I have added. So these are the images that has been loaded into the list X, and also just to show it again. Okay, these are the images. This is chosen at random. Okay, from student 0 to student 6. There are some male students and some female students. And then we encode the training data, the Y array, so just to indicate the student 1, student 2, and so on. And then there is a very nice program, train test split, where you have the X list, okay, which is an array 55 data set with 132 and 101. These three represent the color version. You can use grayscale, but I've just used color so that it will also works on the color images. And Y is 55 why is 55 and 7? Because 55 is the number of images, 7 is the different class of images. Remember, we have 7 students, and we choose to, out of those 55, we choose to take 25% of the data as the test. So we're going to train our CNN with 75% of the data, 25% will be for testing. This is just a random number state. Okay. Now this is the one where we can play around with. If you refer to my previous video, the CNN starts with the convolutional layer. So we just feed the raw images. So this is different than the cancer image that we did before. Cancer image, we just use the features that that has been taken from the original image. Here we feed the original image to the network directly. So of course you need to import the model. We will be using the sequential CNN, and then we use the convolutional neural network. Okay, explained in the previous video. And of course we can add several layers. How do you add a layer, a convolutional layer? You just use this. We call the model, I just use model as the CNN. Okay, you can put any name here, and then you can add in series of layers. So I've used convolutional layer with filter size. Remember the filter size 16, 32, 64, kernel size 5 by 5. So these two are subject to your own design. Okay, so you don't take this as a one and only solution. You can possibly improve it further. So I've used several convolutional layers, 1, 2, 3, 4 here, and then we flatten it and we we supply the resulting pooling data to the dense network. See, we are still using dense network. Remember in the previous example we used just the dense, but we feed the data from the Excel file containing the features data. Here we just use the original image, we use the convolutional layers and pooling layers to extract features automatically, and then in the end we have we downsample it, and then we just use a network. We use the reactive linear unit for the final layer, and then finally we use the softmax, the probability function, which was explained in the previous video. And then we can train. Of course, there's another function that you can read on your own, image data generator. What's good about this function is it will supply the original image and scale it, rotate it, so that the network can view different version of the original images. So here we have rotate, zoom randomly, shift image. This can be done using this image data generator. And then you use this data gen feed the training data, which is this training data is being used to generate this training data using these functions. And then you compile the CNN, okay, using the optimizer, Adam optimizer. Of course you can change all these parameters later on, the learning rate and so on. The loss function is categorical cross entropy. We didn't learn this in class. We use quadratic square error for the loss function, but this is a different version, but you can read on your own to discover about it. And then model summary. After you have done that, then if you apply this code, you will see the model structure of your CNN. And then you can train your CNN using the model feed generator. Okay, this is the syntax for training the model, and the model will be trained for, in this case, for 100 epochs I've chosen so that it's not too long. And then you can see that the error function or the loss function is getting better and better. I mean, it should be less. and then we test the prediction. So we have two parameters, model, this is our model, supplied with the test vectors, and then we check the output of our CNN, and then we also have the actual Y value. So over here, if you this is code is just to compile how many correct and how many wrong images. So at the end here, these are the correct image that we obtain, and this is the wrong image that we obtain. So if you just print this prediction, this line shows, given the test images supplied to the CNN, what is the prediction of the CNN network, whereas this is the actual image used. Okay, so by right, the values on top and on the bottom should be the same, but you can see some is not right. So for example, correct is this one, and wrong is, for example, the first list is wrong. So the prediction is student number 6, but in actual is student number 3. So you can see where the CNN got it wrong. So this is student 3. It is a different student, but probably the network doesn't have enough data. I think the problem is not because of the design of the CNN. We really just have 51 data, which is really too small to use in this example, but nevertheless you can see the network got it right for majority of the data. So you can see the one that it got wrong, which is this 01, number 2, so 012, again same students, so student 6 and student 3, these two I've just printed out because that's a typical outcome of this program. The CNN got confused with these two female students, probably because it's grayscale and both of them are wearing the tudong, the veil. That probably the reason why. And let's see, student 5 and 3, this is not right. 2 and 3. So student 5, okay, normally student 3, so maybe if you just refer to student 5, which one is student 5? Is this student? So student 5, somehow I got confused also. But this is the two students that 6 and 3 is a typical wrong result for this particular scene, and the one that I have just designed very quickly. So probably you can improve on it. Oh, but in the end, if you look at this, I have a link supply links to a real problem. This is just a test problem, so that you know how to load the image, you know how to write the syntax to start off with the training, manipulation of the image data, and the training of the CNN. So if you want to add more layers, you just add more lines. For example, in this case, just add additional lines. So for example, if I want to add additional line, I just if I want to add additional layers, so just copy it. So now I have additional convolutional layer with filter size 64. I can choose to reduce or increase the size. The type of filter will be automatically chosen by the TensorFlow and Keras. Of course, there's a function where you can change that. The size, you can change the size, but what type of filter, you should refer to the Keras documentation, which is easily loaded here, so you can just key in whatever you want to look for, especially related to the CNN. So last but not least, I just would like to show you real image data. Remember, we are just working with 51 number of data, but this is real data. So for example, here you have 50,000 images. Compare 50,000 to 51, that's huge difference. So this is real problem. So you can use the flower dataset. The flower dataset contains 4,242 images of flowers. So different flowers. So how to do that? So you can try just to change part of the code to include. You need to have the actual images of, or you may just supply the link to the image, and then you run your neural network, your convolutional neural network on those train, and then you test the network using the test data. Okay, I hope you have learned something, and please refer to this file to get you started with. Okay, I've given it in e-learning here, so I hope this is something that you can work on while you are staying at home. You just need minimum internet connection and the Google Drive, and you can just run Google Colab where the server is running the program for you, so you don't really need to have a powerful computer at home. So thank you everyone. uh, there's two more topics to talk about in this course. I will try my best to complete it as soon as possible. Thank you everyone. See you next time. Assalamualaikum warahmatullahi wabarakatuh.